Hi, welcome to the Learning Lounge. My name is Ying Zheng, and I'm an instructor in the chemistry and biochemistry department. I teach general chemistry and also the chemistry for the life sciences stream.
And my name is John Ng. I'm also an instructor with the Department of Chemistry and Biochemistry, and been here a lot of years, 38 years now, and I've taught a lot of the different courses. But today, I think what we want to talk about is first and foremost is our interest, our common interest that Ying and I have with teaching and chemical education. Ying is very involved in the teaching center, lots of innovative things that Ying has done, and myself, I'm with the College of Chemistry of Canada, the C3, and I guess what we're talking about today is the agility zone and things that exciting things that happen at the agility zone. And Ying, can you provide me with some backfill as to what brought you, first of all, to the Agility Center and some of the capabilities it has? And then I'll share with you what brought me to the Agility Center. We've both seen it, everybody sees it. It's such a great spot.
Sure. Ever since 2019, the Science Commons building opens, and then we are all kind of attracted to the Agility Zone, which is a big, huge room with lots of fancy toys. But most of us at that time probably didn't really know what we can do there. So actually in 2023 summer, one chance meeting that I met Dave Hinger. And then I was asking him, what and who can actually use the Agility Zone, which is also called Innovation Zone. And then he said, everybody can, you're welcome. And then he told me a bit about what they have. He said, we have 6 3D printers. And at that moment, my eyes just lit up. I was like, wow, 3D printing is such a high demand work skill that it definitely is good for the students to put in their resume. So I'm like, I will want to have my students' hands on it. So I asked him to introduce me to the Agility Center staff, Valerie and Leila at that time. And they gave me a tour, and I was, of course, amazed by the vinyl cutters, the 3D printing and the laser cutters and stuff. But I said, okay, the first thing I want to try is 3D printing, because, you see, as chemists, we always use software or our mind to study the 3D molecules. But now that, maybe we can actually have the student incorporate the 3D printing into this part of the lab learning and have the molecule come in their hands. And so I designed to put the 3D printing as a lab portion into the chemistry for the life sciences 2 stream Chem 2120 courses. And in spring 2024. That would be probably the first ever time we offer 3D printing class on campus. And of course, the first step of 3D printing is to use a software called Tinkercad to actually design a model and play with it, like this kind of things. And the expert of this is Rob in the project sandbox in the library. So we get him to come to our first meeting in the beginning of the term to do a 19-minute hands-on workshop. Students bring their laptop, and then they start playing with Tinkercad. And then after that, and I told the students, then off you go. You are going into the innovation zone, and the staff there are very helpful, Kevin and the other students and the other people. And then you are on your own. You have 2 months. At the end of 2 months, you're going to come and show me this, right? So, and I wasn't actually expecting wonderful things like that. I was thinking much simpler things the student can produce, but actually the result just amazed me. Now you can see, John, that I have all of this harvest in front of me. I'm so proud of this first experiment.
It is very exciting, and I'll share with you what brought me to the innovation zone. And first, everybody sees it, it's such a bright spot and lots of toys, as you pointed out. But what brought me attention and the possibilities was seeing you at the presentation of the recent Spark Symposium, and the excitement and the passion you brought. You just exuded all types of excitement, and then the testimonial from your student that actually went through it. And as we're all aware, we're all cognizant of the fact that students learn very differently, and that one student that you brought to provide some feedback and some evidence, he was so excited as well, and he exuded that same passion, and you turned him on to, wanting to learn more about chemistry. And you're right, we're limited in terms of trying to see models two-dimensionally, and it's wonderful to have this and be able to make a molecule like this and be able to visualize how everything is, the connectivity of it, right? So so that to me was brought that excitement and introduced me to it. So I'm looking forward to the workshop in the 3D printing that the Agility Zone offers. I went through the first one with you as well on laser imaging, and the course that I teach, of course, is Chem 500. It's a bridging course for those students that didn't take chemistry, and now decided I need it. I need it for university chemistry because I want to be a medic, I want to be a nurse, I want to be a dentist, or whatever it is that they need it for, right? So I want to be able to incorporate that and perhaps 3D printing after we have that workshop. So I'm excited to see what it brings.
Yeah, I saw you and when we were at the laser cutter workshop, and we all get to play with our name tags, and you actually, we come up with, maybe have them make periodic table, right? This kind of things, and it is, the students taking my Chem 2120 class, they are not chemistry and biochemistry majors, so chemistry is not their strong passion, right? But it's nice to see that because we introduced this new fancy toy, they actually got very excited. For example, the student you are saying that he actually spent hours and hours in the Agility Zone himself, got 24-hour access, and then he even come up with, I just asked them to bring a molecule, but he came up with that connectable toys that he said, in that you can even give to your student to play with. And so right there, and actually this is exactly the purpose of Agility Zone, is that, hopefully the student or other people using it have the spirit of entrepreneurship. They can even actually spin off to something that they can make more, or they can start having a company or something on their own, and make more things like this and spin off into a business. It's very interesting, especially these students, they're not chemistry major, but when they hold their models, when we have at the end we have a 3D printing product summit. So everybody bring in their models, and of course you can see from that these we see here, they have their individual character. So they put their personality in the design, in the coloring, and then when they were holding these and talk about them, they, like John said, they are passionate. And another thing I like to see is that they are actually very accurate, right? They start talking about the size of the atom, the length of the bond, and the difference between double bond and single bond. And it's so nice to see how they are using the language, right? Actually, in the talking, which is something that they probably don't want to do or don't have a lot of interest in doing because they are not chemistry and biochemistry major. So I think by incorporating the new technology or something that's related to, another example is that the student who actually designed a set of model, he said he got an independent study job just because he knows the 3D printing skill. So definitely these are this learning experience is very transferable skill, and it's a shining piece in the resume, and it will, definitely encourage the student to go more detail into the chemistry, or into learning, or into innovation, right? Yep. Like the word innovation seems to make us feel we need to be innovative in teaching, and our students need to be innovative in learning. So the whole innovation zone is actually very exciting centerpiece that is have a lot of positive output for the university.
I like the fact that you brought up the entrepreneurship, right? I
Yeah.
remember when I went through organic chemistry, and you had to make models of these using these kits, and now the students are making their own model kit. They
Yeah.
learn so much from it, right? They
Yeah.
can look at a carbon and go, okay, there's 4 valence electrons, and now how many bonds can we form around it? And there's a lot of learning there, right? And you mentioned the fact that a molecule, like you just showed there, showing the bond lengths and actually the accuracy of the bond length, right? The double bond is a little bit shorter, et cetera. All of that is there.
Like the fact that they make this benzene ring shows that they know this is a hybrid, resonance structure. And I mean, another thing is one student even was holding a molecule and saying, this is the molecule that keeps me calm. So he's incorporating his learning, his life, and then everything together. And then many students, when they are presenting their models, they also came up with a page of writing of the benefit of the molecule, the structural characteristic, or some of them get molecules from fruit.
Yes.
And I talk about health. And so, you can just see that if you put a subject that the students are interested, actually they will just, go off and then on their own. You don't really have to push them.
We teach a lot of different courses, as we've alluded to, Ying, and I'm going to ask you about some of the challenges, perhaps, of adopting something new and innovative as this, to whether you've given any thought to, you and I have taught Chem 1000 before. It's content laden and very heavy. How would, perhaps would we want to introduce something like that, and how might we approach introducing something such a heavy course with so much fundamental material that we have to cover?
Yeah, this is always a challenge.
Yeah.
For example, this class, the fact that I can actually do it is because I only had about 24 students in the spring. And usually this class is capped at 40. And I think with discussion with the agility zone, and we all feel like your class too, class size of 40 is probably manageable for them and for us. Now, but I still want to bring for example, in the fall, like right after the 3D printing and the laser cutting workshop we had last week, I still want to start to introduce my students to the Agility Center earlier. For example, in the fall, I'll bring my 1110 students. The 1110 students is the class before the 2120 class. I want to introduce them, at least give them a tour of the innovation zone to see what we have here. Right? It's just like the live periodic table is an asset for our university, and we're so proud to show our students that. And then we sit in the first class. Usually our lab first period is meet and greet. We'll bring our students. We'll not only show them the locker, the lab, the film hood. We'll also show them the periodic table, and then just half an hour in the Agility Center, and to show them what we have, what they can do either as a course project or on their own interest. They can go explore what we can offer, what the university has to offer to them. I think that's my plan. I think you have some plan too.
Well, I do, but back to Chem 1000 first, and I was thinking something like that we could still do as you've done in, I know it's 300, and that's 300 plus students. It's not really manageable, but the lab sizes potentially could be manageable, where perhaps that's something to look at in the future. But you're right. I want to definitely introduce the workshop that we went through. I have an assignment in Chem 500, which has about 40 students, and have them use the laser engraver and cutter. We have an assignment where they have to pick an element of the periodic table and create a superhero out of the properties of that element.
Superhero is your thing.
Yes, that's my thing. And they have a lot of fun with it, but now we want to incorporate, as you said, some of that innovative toys, in this case the laser cutter, where they can now have a takeaway. They can build their little element and perhaps start learning about atomic numbers of their element, and then some of the properties and the superhero that they create. So that's exciting. We're going to give that a go for this fall even. That's my hope. And then we'll see how the 3D printing workshop goes, and then we'll want to incorporate that. And where I see incorporating that is something, again, a visual challenge for a lot of students is VESPR, right?
Yes.
Which is, geometry of molecules. And if they can build it, they can see it, they can feel it, they can rotate
That's
it.
right.
It's still, yes, we have programs that allow them to rotate molecules on a two-dimensional screen, but it's nothing like actually creating and making a molecule, another takeaway, and they can look at it and see the connectivity and see the geometry of the molecule that we always talk about. Right?
Yeah, exactly.
A tetrahedron. They can now actually look at it and go, okay, that's what we're talking about.
Trigonoplanar or a
Exactly.
tetrahedral, right? It's right in front of your hand. So I think, for example, like talking about periodic table, most of the time, or a lot of the times, I have my 1,000 class that has just about 118, 120 students, and that's exactly the size of the element in the periodic table. So, one interesting thing is we can have each of our students adopt an element,
Yes.
make them get to know it really well, and then we can, the laser cutting has the ability to have all the zigzag fittings, so they can actually hook them together, and then at the end we have a big class picture. But of course, these things will start be using, like I said, once we get things started, we get the momentum going, maybe the Agility Center will be overwhelmed. And the materials, the resources will be used a lot. And so, and then if that's what our university really need, like the Agility Center, the director Colleen said, maybe they start thinking about, and also Shay, thinking about other funding sources that maybe we can, have some more investment in that. So it's very exciting to see that we started something, and then we built the momentum, and then we got a lot of support, and the Agility Center staff, teaching center staff, they are very excited about this, and it's just a good thing to see that's happening on campus.
Yeah, I think best practices, that's what we're doing here, right? What is going to help our students learn, and that's exactly that. And you're absolutely right. The Agility Center is a great resource, but it's funded independently. And when you think about 300 plus students going through, the material cost would be, and time would be astronomical, right? So they would need some assistance in terms of getting
funding
that off the
and
ground.
Personnel.
Right? Personnel and so,
but if it's something good for the university, right? And I think it's something that's worth building.
Oh, absolutely.
Because all of these new things, especially 3D printing, it's going to open the students' eyes, and it's going to tell the students, it's something we have different. Right? I think our live periodic table and Agility Center and our beautiful science building are all a lot of plus for the university that to attract new students and new, personnel. Yeah.
And it's just not just the science, is not chemistry. I mean, I can see adopting it for any academic unit, any instructor that wants to perhaps incorporate it into geography or geology to make topography maps, for example, right?
Yeah.
That is all possible.
Yeah, like the other day when we were doing the workshop, we saw Will Smith from Fine Arts.
That's right.
Playing with the 3D printer there. And I think the lady from the
sociology,
yes. She was teaching, and she's interested in getting something started.
Right.
And so I think, not just for the molecules, right? We can use them definitely to do a lot of projects. For example, they have some library or museum projects that you cannot use to hold in your hand, but you can make a 3D model, and then you actually can have a facsimile of the precious project.
Oh, for sure.
There's a lot of ways to make use of what we have here, right? I think. What else you have in your mind?
For me,
So you still have a lot of questions for
I do.
me.
I do have questions, and to me, the number one thing is, again, coming back, circling around to the biggest hindrance, of course, is the fundamentals, right? What can I cut out in order to implement something as exciting as this, which I want to do? But if I want to do laser cutting and imaging as well as 3D, now I have two fundamentals. I just kind of envision what instructors of courses that require the fundamentals. So Chem 500 is of course the Chem 30 equivalents, and you need that as basically to prepare students for university chemistry. So if I leave out a fundamental like gas laws, when they get exposed to or require gas laws in Chem 1000, if you had that student, you'd be going, John, why did you not teach gas laws, right? So that is always a concern for me in terms of I want to make sure my students have the proper background to succeed moving forward. And it's exciting. And I think to allow them this skill set to do something like this, you'll be able to see more eureka moments, right? Things that they never ever got before. And now they look at it small and go, I get it. I know what they're talking about now.
Yeah, I think it's always a challenge as an instructor that you have to always choose. And I always say to myself that all times the teachers want to teach you what they want to teach. But I actually think we should teach you what the students need to know. Yeah. Especially in these modern days for the job market. If we can balance and put the students' interest first and foremost, and say what they actually need to know, what will help them to get a job. Right. And then maybe, if, for example, I'm not saying we should cut gas law, but we can make it a reading project. Read it, but I'll give you an exciting hands-on experiment. For example, I replaced one lab. I have to give up one lab, right? And the lab I replaced is bromination of cholesterol. Okay. Which is also a lab I love, because the cholesterol, again, it's a molecule that is in everyday life, and I want students to actually play with it. But the bromination that we use bromine with acetic acid is very corrosive and dangerous. So it's like, maybe I can cut it because it's environmentally not friendly, it's dangerous in the lab, and it's corrosive, and then compared to 3D printing. So that's how I kind of managed to have the courage to cut the material. Because I think we teach bromination in lecture, right? So they know it. And they don't really have to see how corrosive bromine water is in the lab. Right. But they have a knowledge about it. They know how to identify with the bromine water, the color disappearance, and all that knowledge they have. But I think having the chance to do 3D printing definitely has more outcome for the students and have more excitement. So from the students' angle, I think they will love 3D printing more. So this is why we call it a good teacher, teaching what the students need to know. Right.
I think you can still cover bromination of cholesterol.
Yeah, you
Perhaps
cover it
if you
in
build
lecture.
you cover it, but you build the molecule and show it. And then they can kind of see what's perhaps leading.
Cholesterol is a little bit harder for first time 3D printing design. And they can grab the molecule maybe from somewhere. But you're right. So there is a lot of, it's a playing field where the instructors are constantly learning as well, always thinking. So I think innovative zone make all of us also innovative. To challenge ourselves first, and then to challenge our students. But that's what we love to do, right? That's exactly the reward of teaching.
As much as I say covering the fundamentals is really, really important, your point is a very good one too. As long as they're exposed to it, we don't have to go in depth, because I'm a strong believer that university education is not about just learning the facts. It is about learning how to learn, right? And so if we expose the students to, say, gas law, and now they have been at least exposed to it, they can, if they need more, when they get to Chem 1000, perhaps we didn't cover it as in depth as we needed to, they know how to get resources to learn. Right?
Exactly.
And that's so much more important.
That's, yes, if we teach them how to learn and how to be resourceful by giving them an interesting project, and then they got that learning skill, they got that study habit, they got that momentum, then you can give them any subject they can learn on their own. And that's the purpose of university, right? I think after 4 years of education, if our students know how to learn on their own, and also how to, look around the environment and make use of whatever is available for them, I think that's the biggest achievement.
Yeah, I think education, the trend has switched quite a bit. I mean, there was a point where when I first started here, some of senior administration would look at, us introducing, how to use a 3D printer as well. If that's the case, they can just go to a tech school or a college. And to me, I think that's just a wrong way of thinking. We've come a long ways from that now, right? I think it's an important skill set to expose them to more current innovations, right? In this case, current technology, which is what we're doing here with the Agility Zone. And I think it's a valuable resource, and I'm glad to see it here on campus.
Yeah, incorporating their knowledge with real life examples or with hands-on activities is part of experiential learning, and this is a big thing these days, right? Yeah. And I'm sure whether the funding agency or the government or the university, I don't think they will say no to good things that help for experiential learning.
Absolutely.
Because we know as teachers for so many years. I've been teaching for also 20 plus years. We know that students, the three things that you hear, you forget, you see, you remember, you do, you understand, right? This is from Confucius. Yeah. And I think nowadays we know that this is actually the right way to help our students to learn.
We're such kindred spirit, and those are my teaching philosophies too, right?
I know, that's why we're neighbors.
That's why we're neighbors. I guess the caveat of everything that we're saying here is to expose students to new things, new technology, and that's what makes it exciting and makes us want to teach what we teach. We have so many new technologies. In the past, when we characterized something that we synthesized, it used to be basically wet chemistry that we did. It's still important, but we have now, state-of-the-art IRs. We just got an analysis, right? Those NMRs, benchtop NMRs.
Yeah, I'm thinking how to do incorporate an NMR as well.
So I just tried that last spring, and it was well received. It's brand new. It's a starting point, and now in organics they can go in more in depth about spin coupling, etc. Right? So.
Yeah, I think it's playing with the instruments. Again, thankfully for the funding, we got some new instruments. So funding is always important.
Oh, for sure.
Give us the instrument, give us the tool we need. We'll do wonderful things for our students. I think we had such a nice conversation. Before this, I was like, whoa, what can I say? And then once I opened up my mouth, I feel like I have so much to talk about, and I feel my students' excitement is still on me. Yeah. And just by, having all of these things in front of me, I can feel my students' excitement. I gave them very little mark for this. It's only 25 marks out of 180 lab marks, which is only 25% of the course. But they spend a lot of their own time going into the Agility Center. They have to pass all the signer waiver, pass all the training modules, all of this at their own time. And it shows that if the students like it, they don't care about the time they invest. Yeah. They will go in there and study. And I think that's what we need to do more, is to find things that engage our students. I think engage is the big word.
Yeah, that's right. That's right. Yeah, and I thank you, Ying. I mean, you've answered a lot of questions for me in terms of being somebody new to the Innovation Zone, and you've answered questions in the past, and now I'm sure I'll have more questions as I build an assignment to incorporate into my teaching.
I'm eager to get feedback from you too and see how you got from your courses, because it's through this kind of conversation and exchange we can build our best practice in this type of things. I'm happy to be the guinea pig of the Innovation Zone, and I will be so happy to see before I retire that more and more people are using it, and then the whole university is excited about what we have here.
Well, thank you, Ying.
Thank you. Yeah.